Hello, my name is Evie, and I'm a second-year engineering student studying creative technology and design at the University of Colorado Boulder. Today's lesson is all about rocket ships and how they work, and I have HelperBot here, who likes rocket ships a lot, to help out. How do you think spaceflight works? Do you think rocket ships use air to move? What about force? What elements make spaceflight even possible? Don't worry, the answer to these questions will come soon, so stay tuned. But before we dive right into how rocket ships and spaceflight work, we're going to take a look at some history first. It's good to know the events that led up to our spaceflight capabilities, after all. Back in 1609, Johannes Kepler discovered that the planets went around the Sun in a pattern similar to an ellipse. He also came up with a universal law of gravitation that explained objects orbiting around stars and planets. And, last but not least, he proved that the Sun was at the center of the solar system, as many people back then believed that the Earth was in the center of the universe instead. Moving up the timeline a bit, we have Isaac Newton. In 1687, he published a book about his basic laws of motion that applied not only to the objects on Earth, but to space as well. He came up with a universal law of gravitation that helps explain the orbit of objects around stars and planets as well. We also have Konstantin Tsiolkovsky, who figured out all the basic equations of rocketry back in 1903. He believed space travel was possible at a time when most people thought it was just a dream. He even solved problems about rockets that engineers would face many years later. He also predicted how the Saturn V rocket would operate for the first landing of humans on the moon 65 years later. In 1926, the first liquid-fueled rocket was launched, designed and built by Robert Goddard. While his rockets never reached space, they were important in designing rockets that would make it to space in the 1950s. The first spacecraft to make it into Earth's atmosphere was the Soviet-built Sputnik 1 in 1957. The next year, the United States launched its first spacecraft, called Explorer 1. Explorer 1 helped scientists study the energy that comes from space around the Earth. The first manned aircraft was in 1961, where the first person to be on a spacecraft was Yuri Gagarin, in which he orbited the Earth. Shortly afterwards, John Glenn orbited the Earth in 1962 as well. Eventually, in 1969, Apollo 11 was the first manned mission to make it to the Moon. Many manned spacecraft after that include space stations as well, intended for more long-term stays. At some point, the International Space Station, or ISS, was built as an international project between 5 other space agencies. Of course, there can be complications with sending manned missions out to space. Engineers need to make sure they can make it back safely after all. When a spacecraft comes back to Earth, it has to slow down so it doesn't crash. Engineers figured out a way to do this by letting the air around Earth help slow it down. But when it moves through the air, it gets very hot. To keep it safe, engineers cover the spacecraft with heat-proof metal and make it come down at a gentle angle. Finally, a parachute opens up to help it land softly on the ground. This isn't a problem engineers need to solve for unmanned spacecraft, however. We have many unmanned spacecraft out in space right now. Unmanned spacecraft, or robots in space, can do lots of different jobs. There are 5 main types. Space observation satellites. These look at the sun, planets, stars, and the universe. They can see kinds of light, like ultraviolet or X-rays, that we can't see from Earth. Earth observation satellites. These watch our planet from above, helping with science, weather, and even maps. Environmental satellites. These study space itself, like checking radiation or the solar wind around Earth. Helping satellites. These are used by people for communication, GPS, and other things that make life easier on Earth. Exploration spacecraft. These travel far away, exploring other planets or parts of space beyond Earth's gravity. Hey, HB, wait! Come back to Earth. After all that history and background information, we can finally move on to how rockets work. Have you ever heard of Newton's laws of motion? Today, we're only really focused on Newton's third law of motion. His third law of motion states that for every action, there is an equal and opposite reaction. For example, if you were on a skateboard and you pushed off the wall, you'd start moving away from the wall because the action is to push against the wall, and the equal and opposite reaction is the skateboard moving in the opposite direction. This means that a rocket can move forwards by pushing hot gas backwards. There is no air to push in space, so a spacecraft can't fly like an airplane can. Instead, rocket ships make power called thrust with special fuel that is put in a combustion chamber and set on fire or ignited. When ignited, this very hot gas expands, creating a ton of pressure that is released from a small opening. This then pushes the rocket in the opposite direction that the gas is being released from, and then we have liftoff. Take a look at this diagram. This is only a few general parts of the overall rocket ship, as it's a lot more complicated in real life. But this gives a good gist of the parts of a rocket ship from the nose cone to the fin. In the structure system of this rocket, we have the frame for the most part. We also have a payload and guidance system at the front. The nose cone helps the rocket ship slice through the air so it can move through the atmosphere and go into space. The rest of the ship is mainly made up of the propulsion system, where the fuel, oxidizer, pumps, and nozzle resides. A rocket ship needs a lot of power in order to fly. We might also see heat shields, antennas, parachutes, computers, solar panels, thrusters, and more on a typical spacecraft. Heat shields protect the ship from the heat of re-entering the atmosphere, while parachutes are released to give the spacecraft and anyone inside of it a safe landing. Antennas are also important for communication with the ground and for sending scientific data, while the computers monitor the spacecraft and help the astronauts operate the craft and perform experiments. Engineers also use solar panels in order to help provide the spacecraft with power as well. Lastly, we have thrusters, which are smaller rockets that help steer the spacecraft while it is in space. With the help of engineers, we are ready to fly. With this new knowledge, do you think you can make your own rocket now? Maybe not on the same scale as a spacecraft yet, but as an engineer, you can learn and work your way up. Without engineers, space travel would not be possible. It's thanks to them that we can travel to space. And one day, you could become an engineer who works on spacecraft as well. How cool is that? Anyways, that's all for today. Thanks for watching, and we'll see you next time. Check out the full lesson on the Teach Engineering website. Then, check your knowledge of Newton's third law of motion by building paper rockets and pop rockets, or by testing balloon rockets in rocket power.